Your cloud budget projected $500 a month, but the actual invoice arrives at $5,000. Enterprise retrieval augmented generation infrastructure bleeds capital because the origin of the cost is widely misunderstood. Engineering teams often budget for cheap disk storage, overlooking the physical constraints of vector search algorithms. Converting raw documents into mathematical embeddings increases their physical footprint. This is the data amplification effect. A single kilobyte of raw text expands into roughly 15 kilobytes of high-performance data payload. The hierarchical navigable small world index geometry requires rapid, constant access to function. This architecture forces the expanded data geometry directly into random access memory, bypassing cheap disk storage entirely. Budgeting around raw document size rather than embedding memory architecture ensures the RAG system will become a financial liability. The ingestion pipeline acts as the primary choke point for this capital leakage. Engineering teams often vectorize decaying corporate data to avoid the labor of manual curation. This results in the embedding of 10-year-old out-of-office replies and duplicate vendor contracts. Blind ingestion inflates storage costs by 70% and poisons the retrieval pool, causing internal hallucinations. A Pre-RAG Data Sanitization proxy stops the bleed at the perimeter before documents reach premium embedding models. A lightweight edge script intercepts the unstructured file stream before the API call is executed. The proxy algorithm analyzes document metadata and cross-references it with trailing interaction telemetry. The proxy automatically drops the dead files. Only high-signal data passes through to the vector database. Vectorizing uncurated drives forces you to pay for the mathematical mapping of a decade of digital hoarding. Dropping these files at the edge is required to secure retrieval accuracy. The physical geometry of the vector index multiplies infrastructure limits. For domain-specific tasks, transitioning from 1,536-dimensional models to leaner 512-dimensional models reduces the load. Scalar quantization provides a mechanism to shrink the memory footprint even further. Compressing 32-bit floating-point vectors into 8-bit integers slashes memory consumption by a factor of 4. Beyond storage, query compute must be tuned through the proximity parameters. Dropping the search threshold from the default of 200 down to 50 sharply reduces the compute requirements. This tuning cuts overhead significantly without degrading retrieval precision for the end user. Applying these mathematical restrictions frees critical hardware resources and restores operational margin. Every user session often wastefully rebuilds identical enterprise context. Treating the key value cache as temporary memory forces GPUs to repeat identical prefill work for the same corporate documents. A persistent cache converts temporary compute into durable enterprise knowledge. Multi-tenant management adds further overhead when isolated indexes are deployed for every individual client. Shared indexes, isolated by metadata filtering, divide the infrastructure cost by the total tenant count. Self-hosted databases should be mandated for indexes under 2 million vectors, reserving managed services for high-volume scaling. Separating context from temporary runtime memory is necessary to scale cognitive capability without scaling the server footprint. RAG infrastructure requires continuous operational pruning to survive, and maintaining this strict discipline requires a mandatory engineering audit checklist. Step 1 identifies all indexes lacking query traffic in the trailing 30 days. Step 2 involves moving dormant tenant pods out of RAM and into cold storage. The final step identifies orphaned indexes to be systematically destroyed, reclaiming active memory. These maintenance cycles return control to the operator. They ensure that server resources facilitate actual knowledge retrieval rather than unmonitored waste. Ignoring these physical realities ensures that engineering output will fail to align with the balance sheet. Deploy perimeter defenses. Compress the data geometry. Stop paying algorithms to memorize garbage.